A parallel plate capacitor is charged by connecting it to a battery. You can approximate the capacitor plates as infinite connecting planes. The battery is then disconnected. I should underline that so I know it. Disconnected. You then double the separation distance. Double the separation distance between the plates. After this, what will be the charge, field, and potential difference? Okay, so first thing we do is draw a picture. So I'm going to draw a picture like this. There's one plate, there's two plates. This one will be positive, this one will be negative. There's going to be a battery between them that maintains this delta V. There's going to be some charge on this plate, those two negative charge on this plate, and this distance here is going to be delta X. So this is going to be scenario 1. Then scenario 2 is we disconnect the battery and we move the plates twice their delta X. So I'm going to do it kind of like this. Here's the plate with, again, same amount of charge, specifically 3 of them. So now positive, negative, battery disconnected, and let's see, what do we got here then? This will happen, charge electric plates, yes. So now we have 2 delta X between them. All right, so the other thing I want to do for this, so now first thing you do, draw a picture. Second thing you do is you write up a formula that you think might apply. Just every formula you think might apply. And the one I'm going to do for this is E equals, let's see, it's sigma over 2 epsilon naught. And this is one that's just supposed to be memorized. It can be derived, I think, using Gauss's law. Just memorize. So this is the electric field for a plate, which means the electric field for 2 parallel plates is just sigma over epsilon naught. So if you have one plate, sigma over 2 epsilon naught, you have one plate, sigma over 2 epsilon naught, you have 2 parallel plates, sigma over epsilon naught, because you have 2 of them. And the idea then is this is going to create a uniform electric field regardless of distance, with it coming out of the positive and going in to the negative. So these fields are going to reinforce each other. And that's one of the reasons that parallel plate capacitors are used, at least for a lot of physics problems, is that they create mostly a uniform electric field between them. All right, so now the charge on the plates, so the charge on the plates will be the same, because when we disconnect the battery, the charges are basically trapped on there. They don't have anywhere to go. They are a conducting plate surrounded by insulator, i.e. air, and therefore they can't really go unless you get a really big charge, and then, you know, when you get high enough voltage, everything becomes a conductor. But we're not at that point here. We're just normal battery. So the electric charges stay the same. So get rid of this one, get rid of that one, because there's charge on the plate. The electric field is uniform regardless of distance. So this one's going to go away. So it's down to C or D. So the electric field and the charge, electric field, both stay the same. Now we want to know about the potential difference. So the easiest way to see this then would be that the formula for voltage. Voltage equals negative E dx, which in this case is going to be negative integral sigma over epsilon naught, because that's going to be our electric field, dx, negative sigma over epsilon naught, because it has a uniform electric field. It's basically, it's constant. And so the potential for a 2 parallel plates, integral of just dx is going to be x. So it's going to be negative sigma epsilon naught delta x. And let's see, potential difference between the plates. So this, now what I'm hesitant about here is the negative sign. So this is, so this would be negative sigma over delta x, and this would be sigma over epsilon naught 2 delta x. Now the reason I'm going to say that 2 has more potential because potential is related to energy. Potential is Q times, it is Q times E. No, force is Q times E. Work, which is energy potential, which is sometimes written as a U, is charge times voltage. And really it's going to be charge times delta V, because voltage is always a difference. So with this, when they say what is the potential difference between the plates, they're asking what's the energy stored due to the charges on these plates. And if you think about it, these two plates are attracting each other. So if you pull the plates apart, what you're doing is you're storing more energy into them, because when you finally let go, there's going to be a bigger crash or a bigger clunk when they hit each other. So by expanding the distance between the two, you're working against these charges and storing potential energy in this. So this right here has more potential energy because we pulled apart these charges, the positive and negative charges. Therefore, it has more potential. Usually the thought process goes the other way. More potential implies more energy, but also true the other direction. More potential energy is going to imply more potential. So it's going to be stay the same, and increase. So hope that made sense. One thing that could kind of throw you off here, the way they could vary the question is, if they had not disconnected the battery, then the potential would have been the same for all of them, because the whole job of a battery is to maintain a constant differential voltage, differential pressure, potential. So hope that helped. See you next time.